Okay, video number 2, KSP. We kind of talked about KSP 2 weeks ago, 3 weeks ago, but I'm going to go a little bit more. You probably want to write down some notes. So number 16, you can put it on the back of the problem set because you're going to have to take a picture of it and submit it. This one, probably write on your own separate notes, like make KSP notes. So if you look, okay, KSP is a measure of how good a solid can dissolve into ions. So like when you mix sugar into lemonade and then eventually you get to the point where it precipitates out on the bottom, you have like the solid sugar on the bottom. This kind of, you're going to compare your concentrations and see if it's going to form that precipitate. So you use this to find out if a solution of two different ions will form a precipitate. Okay, so I took silver chloride, which was a solid, and in solution, so you mix it up in water and it breaks apart into the silver ion and the chloride ion. My concentrations are, and this is a 1-to-1, they're the same. So the concentration of the silver is 4.6 times 10 to the negative 4th molar. The concentration of the chlorine is 4.6 times 10 to the negative 4th molar. Step number 1, do I have a balanced equation? Check. That one's definitely balanced. Yes. Okay, you always want the solid on the left. The solid has to be over here. Otherwise, your K expression won't work because it'll be you can't solve it. So the solid, you have to start off with the solid. So the solid is going to break apart. You're not going to form it the other way. The solid is breaking apart into ions. Step number 2, you're going to write your KSP. So same thing, products over reactants, but we don't include solids. So, sorry, I have this set on a stool in my basement. So right here, K is and it's a special K, right? Special KSP, special K. So my KSP is the concentration of silver times the concentration of chlorine. Okay, so now plug and chug. This is called the trial, the TKSP. Like it almost looks like teaspoon if you've been baking during this quarantine. So I'm running out of space right here. 4.6 times 10 to the negative 4th molar times 4.6 times 10 to the negative 4th molar. We're just multiplying those together. And remember, if they had coefficients, I'd have to multiply by the coefficients, but there's no coefficients. So plug and chug, when I plug those two numbers in, I get 2.1 times 10 to the negative 7. That's my KTSP. Okay, so now you're like, what do I do with it? Well, now you're going to compare it. And if you looked in your packet, you have 3 pages of KSP values. There's KSP values for everything. You would never have to memorize that. You can always look that up. If the KTSP is greater than the given KSP, so you look up silver chloride, and when I look up silver chloride in my kit, the KSP is 1.7 times 10 to the negative 10th. So yes, something times to the negative 7th is definitely bigger. So then if it was asking you for precipitate forms, you would say yes, the precipitate forms. So your first assignment for Tuesday is going to be to start those KSPs. There's some with X and Y, and you're like, oh my gosh, I don't know what the charge is on that. The key thing is you're not plugging in numbers, you're just setting up this expression right here. Okay, so X would be the positive ion, Y is the negative ion. So in those first few problems, you're just setting it up like this, and you're not solving. Okay, good luck. Email me if you have questions. Talk to you later. Bye.